All right, so we're back for activity 3 here. And it says using a double number line. All right, so, and then it gives us this YouTube link. And it says count the number of times you can clap your hands. But clap your hands is throw a ball. Count the number of times you can throw a ball in 12 seconds. Have your partner keep track of the time and record your results. These results complete the double number line. Okay, well, let's go ahead and see what this does here. Well, let's go watch this. It's me again. Okay, so it's really hard to hear. 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, 7, 1,000, 8, 1,000, 9, 1,000, 10, 1,000, 11, 1,000. Give me the ball back. Oh, that dog. 12, 1,000. Oh, 13, 1,000.
That was 3.
3. All right, cancel. Don't need any of this. All right, let's close that and go back over here. Okay, so I threw the ball 3 times in 12 seconds. So I would put the number 3 here, but I can't write into that little box. So I would say threw the ball 3 times in 12 seconds, and to insert an equation, remember what that looks like is that our measurement of time is in the denominator, in the bottom of the fraction. So that would be 3 times in 12 seconds. All right. B, explain how to use the double number line to find the number of times you clap your hands in 6 seconds and in 4 seconds. Well, I'm going to start by writing my equation again. Three times in 12 seconds. Seconds. It's good to know how to spell, guys. Don't forget that. All right, so explain how to use the double number line to count the number of times you clap your hands in, or I'm sorry, this should say fetch the ball. Format, text, strike through. Copy. Paste. Throw a ball in 6 seconds and in 4 seconds. Okay, well, let's go ahead and think about this. So half of 12 is 6. So what is half of 3? Well, half of 3, that's kind of between 2 and 3 is between 2 and 4, and half of 2 is 1. So I'm thinking about this. So if I take 3 and I divide it by 2, I'm going to get over here, I'm going to say equals 3 divided by 2, 1.5. Go back. 1.5. All right. So 1.5 times in 6 seconds. So that would be a new equation, fraction. I would throw the ball 1.5 times in, I'm going to say 1.5. Ball throws in, oh, come on now, 6 seconds. All right. But then it says 4 seconds. Okay, and 4 is even in between here. So I wonder if there is a way that I can turn this part kind of like this and get it down to where it's per 1 second. So let's see here. To reduce this to where it's 3 times in 1 second, I would need to turn this divide by 3 by 12. So let's do that. Equals 3. I'm sorry. Yes, no, equals 3 divided by 12. 0.25. Oops. Oops. What am I doing? All right. So this would be 0.25, so 1/4 of a ball throw. New equation. Ball throws in 1 second. So let's count to 4 seconds. So 0.25 in 1 second, that is the same as let's count by 4. So let's think about this as 25 cents. So 25 cents, 50 cents, 75 cents, $1. So that would be 1 ball throw in 4 seconds. So every 4 seconds, I was able to throw the ball for the dog. Okay. Find the number of times you can throw the ball in 1 minute. Explain how you found your answer. Okay, so in 1 minute, now, let's see here. If I take this, oops, here we are. 1 ball throw. I'm going to do it this way. 0.25 ball throws in 1 minute in 1 second. So how many seconds are there in a minute? Well, there are 60 seconds. I'm going to replace this. New equation. 60 seconds in 1 minute. Okay. So if I take 0.25 and I multiply that by 60, let's see what we get. So 0.25 times 60 is equal to, let's go over here and double check our math. 0.25 times 60 equals 15. 15. So I would have 15 ball throws in 1 minute. Yes, we can explain how we did this in 2 minutes and 3 minutes. We would just keep multiplying 15 times in 1 minute by the number of minutes. So for example, if we did 15 times 2, that will equal, I'm going to use this new equation, multiply 15 times 2, that's going to equal 30 ball throws. And times 3, would equal times 3 is equal to 45 ball throws. Okay, good. What is your answer? In your own words, how can you use the rates? How can you use rates to describe changes in real-life problems? Give examples to support your explanation. Well, here's a good one. We can figure out the number of coronavirus infections per person in Juneau. Okay? To do that, we would say find the number of cases and the number of people in Juneau. So for example, let's go over here. Let's say population of Juneau. I'm going to round down and I'm going to say 32,000. So rounding down, I'm going to say Juneau equals 32,000. Okay. And corona virus cases. Coronavirus cases in Juneau. Juneau, 26. Therefore, we could say new equation, 26 coronavirus cases for 32,000 people in Juneau. There we are. We've done it in our own words. Modeling. Use the double number line to model each story in Activity 1. Show how to use the double number line in each question Activity 2. Why is a double number line a good problem-solving tool for these types of problems? So I'm going to shorten this for us. We're not going to do each story in Activity 1. We're going to do it using 4 coronavirus cases. Coronavirus is how it wants it to be spelled, huh? Okay. All right, fine. Doesn't want me to change that. Okay. So we would use a double number line, and I'm going to draw this out using that drawing tool again, which is going to make my face go away. Okay, so we're back. My face is gone. That's why I was confused. Okay, so we would have 0 cases of coronavirus. And coronavirus, 0 cases of coronavirus, and then we would have the date, or I'm going to say number of days. Number of days. And we'll start with day 0. Okay, so after a certain number of days, we're going to have 26 cases and our number of days down here. Okay, so why is a double number line a good problem-solving tool for these types of problems? Well, what do you think? I mean, it can help us figure out the number of cases per people. It can help us figure out what might happen in the future. and where we go from there. Okay, so I am going to turn off draw and zoom, and it goes away. Turned off draw and zoom, and it goes away. All right, so here's the practice. Write a rate that represents a situation. Okay, so we can exercise for 20 minutes and burn 100 calories for people who are dieting. And we can write that as an equation. Remember, time goes on the bottom. So, wrong thing. This would be 100 calories in 20 minutes. Okay, dollars per boxes. This is a strange one. Okay, we can work at Amazon and earn $12 for every 4 boxes we fill. All right, so let's do that. New equation. 12 boxes per, $12 per 4 boxes. Well, now, except I want to figure out how much I'm going to earn per 1 box. So let's go ahead and divide this. And we're going to divide 12, new equation, operations, divide 12 divided by 4, and 12 divided by 4 is 3. So that means I would earn, new equation, $3 for, for every 1 box. So if I was working at Amazon and I got paid by the number of boxes I filled, I'd earn $3 for every box. Okay. Write a unit rate for the situation. Oh, that's what we just did up here. Our unit rate means that our denominator is 1. So 9 strikes, new equation. 9 strikes. Okay, I've got the equation. But I forgot to hit the fraction. 9 strikes in 3 innings. All right, that's the same as saying 9 divided by 3, and 9 goes into 3 times. So we're going to say that is, new equation, 3, what are we doing? Don't do this to me, computer. 3 strikes in 1 inning. 117 points in 13 minutes. I'm going to skip that one because that's broken at the bottom of the page, and I don't want to divide those out. Okay, so decide whether these are equivalent. So the way that we could figure out if these are equivalent, remember equit as part of equivalent, this means equals. So this means equals. We have to figure out if does, new equation, fraction, 30 beats, come on computer, don't freeze on me, 30 beats in 20 seconds equal 90 beats in 60 seconds. All right. Does 30 beats in 20 seconds equal 90 beats in 60 seconds? So we do this the same way. So we would take 30, and we would divide that by 20, and that would give us 1.5 beats. Let me write it this way. .5 beats in 1 second. It's kind of like a heart rate. And we would divide 90 divided by 60, and that would equal, well, let's go over here, equals 90 divided by 60, 1.5. Okay, and so that equals, new equation, 1.5 beats per 1 second. So the answer here, oops, is yes, that 30 beats in 20 seconds is the same as 90 beats in 60 seconds. Pages per minute, 15 pages in 20 minutes. Same thing, 15 divided by 20 is equal to 0.75. So, oops, 0.75 pages per minute, and 10 divided by 15 is equal to, the answer is going to be no. I know what it is already. 0.66, yeah. And that's going to be repeating pages per minute. So the answer then is no. Those are not equal. All right, one of the valves in the Hoover Dam. Hoover Dam is this big, actually, let's just go take a look. Hoover Dam. And images. All right, so the Hoover Dam is this giant dam in Nevada in the desert near California that supplies hydropower or hydroelectricity to Las Vegas and other places, and which is why Las Vegas, if you've ever been there, has so many lights. Okay, so this is the Hoover Dam. So the Hoover Dam releases 40,000 gallons of water per minute. Oh, per second. What is the rate in gallons per minute? All right, so it is new equation, fraction, 40,000 gallons per second. And I know that there are, and so this is going to be multiplication. So new equation, I don't want to do new equation. I just want to go into this equation, go over there, here. Times, good, I put it in that way. And this is going to be 60 equation seconds in 1 minute. Okay, so now I have to multiply 40,000 by 60. All right, equals 40,000 40,000 piece puzzle. Ugh. Times 60. Not images. Oh. Here we are. Boy, that is 2,400,000. So, where's my equals? Maybe it doesn't have it because I have an equal key. Equals 2,400,000. Oops, other zero. Insert fraction. Gallons per minute. Wow. Okay, that's it. That's all we have to do. Thanks.